Good afternoon. This is Mr. Hoopert speaking. This is Unit 6, Notes 3, Exponential Growth. Now, I'm going to tell you this once and tell you this once only. This is growth. When you grow, you add things together and you get bigger. Plus, I don't know what that is anymore. Now, learning target. I can graph model and apply exponential growth functions. So one of the exponential functions is growth. So here's your exponential growth. You have to remember it's plus. This is the equation. So you're going to take the amount that you start with. You're going to add the rate of change and add it to 1 as a decimal. So if it's a percent, change it to a decimal. All right? And you do that. Remember that 50% is equal to 0.5. We did scientific notation, so if the decimal is here, you move it twice. 2 times is the magic number. Note that the C value is also our y-intercept. Well, we talked about this. The C is the constant out front, so that's going to be your y-intercept, and that's where the value starts at. So let's kind of just show you what they look like. So this is C equals 8, R equals 0.5. So what we have is C equals 8. You have 1 plus 0.45. Now look at this. They have x's and y's. So this is going to be a y equals again with x as our exponent. I wonder what we should start with. How about negative 1, 0, 1, 2, 3. So nothing new. We're continuing to do the same things. Right? Now 1.45, right? Things you can do in your calculator would be like 8 times 1.45. What are we raising the 1.45 to? We are raising it to negative 1 first. Right? Now remember, I get 1.5 by doing 8 times 1 plus the 1.45. You should have the math skills to know that this is probably a better thing to enter into our calculator than this. Now, it is negative 1 is supposed to be 5.5. Alright, so then like one I have entered into my calculator is this right now. So now let's go to the 0. So we'll change it off. We got 0. You're going to get anything to the 0 power is 1 times 8 is 8. Good news, our calculator is doing it correctly because we said our y-intercept has to be 8. Now, if I change it to the x value, the exponent to a 1, now you're going to get 11.6. If I square it, you should get a value of 16.8. And if you cube it, you get 24.4. So over here somewhere on my graph, negative 1 is 5.5, so about here. 0 is 8. 1 is 11.6. 2 is 16.8. 3 is 24.4. So you can see this is still a very large equation that grows. So that's what we're looking for. Now this one was a decimal. So all you had to do was just add it. Keep that in mind. And our y-intercept was our C value. X is 0, y is 8. When we go to the next one, a fraction, alright, you can leave it as a fraction, alright? So if you wanted to, you could have y, it says fraction or decimal. You could have y equals, I'll show you how to do it as a fraction, 1 plus 1/3 x. So negative 1, 0, 1, 2, 3. What I would actually enter in the calculator is 1 plus 1/3 would actually be 3 over 3, which is 1, so 4/3 x. So in my calculator, what I would put is 6, 4 divided by 3 to the negative 1. So 6 parentheses 4 divided by 3 to the negative 1 power. I get 4.5. Now to check, to make sure I did it right, I would change the negative 1, hit delete, put a 0, I get 6. So I know I'm doing this correctly. How about 1? If you do it to the first power, you get 8. And if I second it, I get 10.6 repeating. And if I make it to the third, I should get another nice decimal. 14.2 repeating. So, coming over here. Negative 1, 4.5. 0, 6, good. 1, 8. 2, 10.6. 3, 14.2. Look at this, another growth equation. Notice it's going up, kind of like our parabola. It's opening up. It is getting bigger, and it is a growth problem. So all these are going to be up because it's growth. Now make sure you understand what I actually had here. I'm going to erase this negative 1 for a second. Was a caret key, and then I had a 0, I had a 1, I had a 2, I had a 3, whatever it was, to make sure that we can graph. Alright, in 1971, there was 294,105 females in high school sports. Since then, the number has increased an average of 8.5% per year. Write an equation to represent the number of females participating in high school sports since 1971. Sorry, I needed a drink. So, what did my value start at? So I'm going to write my equation. I'm going to know that it started at 294,105. 294,105. Since then, it's increased. This means growth, which is adding. So I'm going to put 1 plus 8.5. So here's my percent. Now I told you to move it 2. So 8.5%, 1, 2 is equal to 0.085. So I need to put the decimal and the 0 in. So 0.085 to the x. Or if you really wanted to, you could put t. So write an equation to represent the number of females participating in high school sports. This is it. This is the equation. Now it says to calculate in 2005. Well, that's a year. So 2005 minus 1971, I get a 34. Alright, because you'd have to borrow here. This would be a 9, 10, 34. So what I do is in my calculator, I write y equals, you don't put the y equals in, but you do put 94105, alright? And then I would know that it's 1.085 to the 34th power. So you have to know how to use the caret key, right? And you have to know that. One thing you could do is you could put the 1.0835 in the calculator, alright? And you could go, well, I need to put that to the 34th power. You should get a value, 0.085 to the 34th. It looks like 16 times this by 294,105. I get that there is about 4711,004 females in high school sports. So that looks like 4,711,004. Notice I didn't round to a half a person. Alright, people are full people, so you're going to round to the closest decimal. You can, or closest whole person. You can figure that out on your own. So that's what you're looking for. You're looking for the equation piece, writing the equation, and then knowing how to calculate the actual value after so many years. So let's try this again. 2010, the city of Farmington had a population of 21,000 and a growth rate of 1. Growth, increase. So make sure you know 1.9%, 1, 2. So I get 0.019 is equal to 1.9%. This side doesn't matter anymore. That's what I need to know. You need to know this here. So, y equals my start, 21,087. That's my y-intercept. 1 plus 0.019, and this is going to be times. And then what I always do is I cheat a little bit. Alright, what I put in the calculator is 21,087. I add that together, so I know it's a decimal, and I have y equals that. Well, what would be the approximate population of Farmington in 13? Well, between 2010. So if you come up here and look at the beginning next to 4, 2010. So the first one, I would need 3. Right? Then the 17, I would do it for 21,087, 1.019 to the 7th. And so knowing how to enter both of those is great practice for us. So get your calculators out. If you're not doing the calculator work right now, and you're just banking on me doing all of it, and you're going to be able to do it on your own someday, practice makes perfect. You better get a calculator out. So for this one, I just get 22,311, 312. There's a whole person there. So y equals. And then when you do the next one, after 3 years it doesn't really grow, but after 7 years, we're thinking like 24,057 people. So then you can write people here, and in Farmington, 24,057 people in Farmington on such and such date. Alright, an initial population of 750 endangered turtles triples each year. So this would be one where you have to start thinking. Triples each year. Alright, so y equals 750 is my start value. Triples times 3, and then we need to know how many number of years. So that's actually just that multiply by 3 each time. Well, each year you're going to multiply by another 3, so you just know the triples is the exponential part. In 8 years, so it's just y equals 750, 3 to the 8th, right? Y equals these endangered turtles are sure growing fast. 3 to the 8th is like a number 6,000 something. Jeepers creepers. Now we have 4 million of them. This seems uncalled for. Hope there's enough sea animals for them to eat. What do turtles eat? Right? Turtles. Turtle, turtle. There's a movie that says that. Master of Disguise maybe or something? I don't know. Alright. There's your turtles. There's 4 million of them. We don't know what to do with them now. I don't know, blah, 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 blah. Okay, important thing is percents move 2 decimal spots. Percent are bigger than the decimal, so you're getting smaller, so you make the decimal smaller. You also need to know that growth every time is going to mean add. So appreciates in value is adding. Growth is adding. Interest gained is adding. All those key words and word problems. And then you also need to know how to use your calculator very, very well at this point. All right. Thanks for listening. Have a great day.